Here find GCD of 110 and 490. So here we are going to apply the previous concept, like 490 is the greater number, so 490 equals 1110 into 4 when divided by 110. So 1110 into 4 plus 50. Again 1110 is divided by 50, then gives remainder 10, and again when 50 divided by 10, so here the remainder is 0. So 10 is the greatest common divisor of 110 and 490. So the division algorithm also works in the QX, which is the set of polynomials with rational coefficients, and RX, the set of polynomials with real coefficients. For the sake of our study, we will only focus upon QX. If AX and BX are two polynomials, then we can find a unique quotient and remainder polynomials. This is important to understand that if AX and BX are two polynomials, then we can find the unique quotient and the remainder polynomial QX RX belongs to the set of the polynomials with rational coefficients. Such that here AX is equal to BX into QX plus RX, and the degree of R is less than the degree of B for the proper division, and Rx is equal to 0. We present a proof after an example. We can find QX and Rx using long division for polynomials. Here calculate QX and Rx such that AX is equal to BX into QX plus Rx. For AX, 8x to the power 4 plus 3x cube plus 10, and Bx is equal to x square minus x. So now we have to calculate QX and Rx, means we have to find out the quotient function and the remainder function. Here we begin by dividing the leading term of AX by leading term of BX. So x4 phi x square is equal to x4 x square. Therefore, we multiply bx by x square and subtract the result from ax. Then x4 plus 3x cube plus 10 is equal to x square minus x into x square plus 4x cube plus 10. Now, in order to get the right of the 4x cube, the term in the remainder, we have to divide this by leading term of bx x square, that is 4x cube by x square is equal to 4x. We add this to the quotient and subtract the multiplication from the remainder in order to get the right of the cubic term. X4 plus 3x cube plus 10 is equal to x square minus x into x square plus 4x square plus 10. Now one may be tempted to stop here. However, the remainder and the bx are both quadratic, and we need degree of Rx must be less than degree of Bx. So in order to remove the quadratic form from the remainder, we divide the term 4x square by the leading term of Bx, that is 4x square by x square is equal to 4. We add the quotient and the subtract in order to get x4 plus 3x cube plus 10 is equal to x square minus x into x square plus 4x plus 4 plus 4x plus 10. So therefore qx is equal to x square plus 4x plus 4 and rx is equal to 4x plus 10. So we verify that indeed degree of rx is equal to 1, which is less than the degree of vx, that is equal to 2. So here one thing is important to note, that here the numbers will not always come out as nicely as they did in the above expression, and we will occasionally have fractions.